Hi everyone and welcome back. In this video, we are going to work with our host screen and host view model and prepare our local stream at the beginning. So to do that, you will see that we have surface view, which is our local surface view. We want to start it whenever this surface view render composable is ready. So using our host view model and creating start local stream down here, we simply want to use this surface view renderer and start the local stream inside this one. So to do that, we want to have an object of the WebRTC client or the RTC client. So let's add a section here for TC variable. So we pretty much want to have the RTC client of type RTC client, and we will initialize it by lazy. So it will return the RTC client and add the application to it. We have the access to it. For the PeerConnection observer, we will have an anonymous object of PeerConnection observer, which is inside my project. And then for the last parameter, I simply want to, get the message from this callback. So whenever a message is being called, I want to send it to the socket server. So using socket server and send data to client and pass message to it. Simple as that. So inside my PeerConnection observer, I want to override the onICE candidate. So whenever the new ICE candidate is being generated, I want to add it to my own connection and then use the socket server and set this one to client. How's that? Just like this. I'll create a new message model, add the ICE candidate as the type, and use JSON, which I don't have here. I'll add it inside the constructor of the class, simple as that. Using JSON to JSON and pass P0 to it. And the next thing to override is onAddStream. We simply want to get the remote view, which we don't have here. So it's going to be a private var remote view, which we will add it inside this variable whenever our remote view is prepared. So it's going to be of type surface view renderer. And now initially it says, hey, it's a static view, careful about it. And I said, no worries, I'll handle it myself. Down here, I'll check if this remote view is not known. Then I'll check if this media stream is not known. Then I want to use media stream and get access to video tracks number 0 or index 0 and add sync to our remotes. Simple as that. The next function to override is onConnection change, which will give us a new state. So I'll check if new state is equal to PeerConnection disconnected or closed, then it means that our connection is lost or dropped. So we have to navigate back to main screen. So I'll use view model scope and large plug and updates are called disconnected states and add true to it. So I'll create this called disconnected state up here inside states, and down here I'll create the called disconnected. It's going to be mutable state flow of Boolean, and its value is going to be mutable state flow of false. Simple as that. So we'll emit true to it. The host screen that is observing this one will get notified that, hey, call is disconnected. Let's go back to main screen. Okay, so now we have the access to our RTC client. Let's minimize this one. And down here on start local stream function, I simply want to use RTC client and initialize surface view, and then RTC client start local video pass view to it. So inside this start local stream, we simply want to get access to RTC client and start local video and pass view to it. So if we take a look inside here, we simply first start initializing our surface view, and then we start local surface view capturing and previewing. So if I run the application right now, we should be able to see the local video track inside the small screen. So if we press the host, we will have an error here. It says that, hey, you forgot to initialize the PeerConnection factory. That's true. Let's go inside our RTC client and add an init block here. Inside this init block, we will init PeerConnection and pass the application to it. So let's test it again. So right here, we will have our local video capture. Let's actually switch the front facing to is back facing and check if it's working. And yes, it's on the back camera of the emulator. So we successfully started the local stream. But right now we want to prepare the surface, the remote surface view. Let's create a function inside the view model. Name its view. We simply want to use RTC client and initialize surface view and pass view to it. And the next thing, which is very important, is that to store the remote view using this view object. So before we forget it, let's go to uncleared and check if remote view is not null. We want to release it, then make it null. Then use the RTC client and pass onAddStream. So with this job, we will get rid of static fit leak. And let's go back to our host screen. We also can check this state here since we implemented inside the host view model. And we check if this one is getting true, then we want to go back to our main screen. So what we have done so far is preparing the local surface view and the remote surface view. So right now we want to check what happens if our client is being connected and sends the start signal. So to do that, let's actually move to our client's view model. And we simply here want to check if the socket is open. It means we are connected to the host. So we want to send the call signal here. Right now, let's create the RTC object here. It's going to be same as our host view model. Let's go here. Actually, before creating the RTC client, we have to do exact same thing as we have done to prepare the local stream and remote stream inside our client view model. So let's add these two functions. It's going to be pretty much same as the host view models. So let's copy this one, go back to client view model. Let's add the section, the RTC section. We will copy it here. So instead of socket server, we will have the socket clients, and we will have the send data to host. Also, we want to add the JSON object. So we want to also have the remote view of type surface view renderer and not initially, and also surpass the static view leak since we are handling it ourselves. So it's pretty much the same as what we have done inside our host view model. Like this state of call is connected, I'll just copy and paste it. States, simple as that. And for our RTC client callback, which whenever has the message to send to the server, we simply want to use the socket clients again and send data to host. Just like that. So like this, you will have our RTC client variable. Right now, let's go down here and add those two functions for starting the local stream and prepare the remote stream. It's pretty much the same. So if we open the client screen, you will see that, hey, there is a state called disconnected, which will be handled inside this RTC client objects. Here, we'll emit true. The connection is disconnected. And also down here for the remote surface view, we simply want to call this unprepared but surface view using this client view model. Also, for our local surface view, we simply just pass start local stream, pretty much the same. And yeah, so both clients and host are ready to now start the WebRTC process. They started the local stream and prepared the remote stream. So let's see what happens if our client's view model gets connected to the socket server, which this function is in charge to notify the client's view model to say, hey, the socket client is opened or it's connected to the host. So what we do here is simply use the RTC client and use the call function. So let's see what happens here. We connect to the host and we are ready to start the call. So we use this function and check what happens. It's going to create an offer, add it to the local description, and bam, it pops up the message model of type offer and has the description as the data. So it calls it sends message to socket. So let's go to our client view model and check our RTC client initialization. We will see that, hey, if it wants to send a message like this, actually let me make it like this. Send message to socket is equal to this block. Now you get it better. So if it wants to send message to a socket and it has a message inside, we want to use this socket client instance and send it to the host. Simple as that. So it uses the WebSocket, make it a JSON model, and send it to the host. So what happens here, our socket server will get notified using this onMessage and cast it to the message model and notify the socket server. So the socket server uses this listener and gets it inside the host view model. But that's the magic. So this host view model will get notified that, hey, there's a message. So we will use a when state and pass the message dot type and implements all the remaining. So we won't receive an answer. So we will have an else block, which will do nothing or pass unit to it. So we will receive the offer inside the host view model, and then we decide to what to do to the offer. Just like that, we will create this function, and guess what happens here? So this message has a data of type session description, which is string. So we will create a session description object of type WebRTC, and for the type we will pass session description dot type dot offer. So let's import it and make it shorter, and then the description is going to be message dot data to string. Let's make it like this. So we received the offer, added to the remote description, and then we want to answer just like that. So what happens here? We press the answer function, we create an answer, set it inside our local description as the callee, not the caller. Whenever it's set successfully, we pop a message model as the answer, and the description is going to be the description of this session description. And then we use this send message to the socket, and inside our host view model, right, whenever we are initializing this one using this callback here, let me make it like this so it's more understandable. Yeah, whenever it tries to send message to socket, we simply want to send it to the socket server. And guess what happens here? It uses the member to call, check if the client is connected, and converts it to a JSON and send it simply to the WebSocket of the client. And guess what happens here? the client view model will get notified using onSocket client message. So we check it when the message model dot type is answer. We will not get offer ever because the client always start the session. So we simply just ignore that. So whenever we get the answer, we use the handle answer to handle the answer. Simple as that. So what happens here? We want to add this answers session description to our remote session description of PeerConnection. So we use the RTC client and add our remote session receipt and use a session description object of type WebRTC. The type of it is going to be session description type dot answer, and then description is going to message model data to stream. Simple as that. So right now we have exchanged the session description and add them as the remote description or remote session description. So there's only one thing is left. Whenever an ICE candidate is being received, so it's the same inside both view models, same as host and same as client. We will create a function handle ICE candidate and pass the message model to it. So let's create this function. Down here, we use the run catching and then use JSON from JSON. Simply use the message model, the data to string, and pass ICE candidates of WebRTC class. And if it's success, we simply want to use RTC clients and add ICE candidate to it. Simple as that. I'll copy and paste this one inside our host view model and use it here, pass message to it. So before I forget, let's go inside our client view model and handle the uncleared of the view model of the client, exact same as the view model of the host. So let's copy and paste it down here. So for the socket server, we simply just use the socket client. We want to release the remote view and other stuff. So if I run it on my two devices at the moment, we should see everything is working fine. So it's my first phone. They both are connected to the same router, to the same modem. I'll connect it as a host. It's my Xiaomi phone. We should see the camera is working. And also I'll copy this URL and go back to my Samsung phone and type it here. Yes, we can see both phones are connected and we have everything. Okay, so far so good. Right now we have learned how to start the PeerConnection and establish the connection between two clients and the host. So on the next video, we will learn how to use the end call function, switch camera, and toggle audio and other stuff like that. So that's it for this video. Till the next video, see you everyone.